So we're starting with the note sheet from yesterday. This should be the next problem after the last one we finished with. So we did some of these here, writing subsets, writing these in set notation. So for the prime number, the prime whole numbers, because whenever we write in set notation, for the most part, we would start off with this. Now we do this here for integers. We use z with 2 lines. Whole numbers really doesn't have one, so we'll apply that here in a minute. But the main part for this one here is the prime numbers. What is the smallest prime number? It's actually not 1.
0.
Not 0. It is
Negative
2. Smallest, well, this is the smallest positive whole number. It's 2. Well, the next one after it is 3, 5, 7, 11, 13, 17, and they continue on. But as we notice with this here, there's not a set pattern from one to the next. So the only factors for a prime number are 1 and itself. So for 2, 2's only factors are 1 and 2. 3's only factors are 1 and 3. Same with 5, 7, 11, 13, 17. The reason we exclude 1 is because, well, 1's factors are just 1. It doesn't have another factor. It's just 1 by itself. So it's not considered prime because it has to be 1 and itself. We need 2. So 1 is not a prime number, but 2 is the first one. Well, there's no way to list this because I can't say x is just greater than 2 because that's going to include more numbers than just prime numbers. And there's no systematic or mathematical way to define or be able to find any and all prime numbers. If we could, that'd be amazing. Because if we could do the proof of it and show systematically or mathematically a way to calculate or find prime numbers, we'd be $1 million richer. There's actually a Millennium Prize for that. That it offers $1 million for anybody that can actually prove it. A good number of people have tried. A lot of people have tried to figure it out. No one has gotten there yet. A lot of people have made good progress, but they have not made it yet. As to it a little bit, but I'm nowhere near. There's 10 of them, and only one of the 10 has actually been proven. The person who proved it stated that he just worked off of other people's work that had been submitted or whatnot. Not so much for publication, but kind of saying what they've done or how far they've progressed. And he was actually able to prove one of them. It was about geometry. And he declined the prize money. Yeah. Because I think the quote that he said is he did it more for the sake of doing it, not so much for the sake of getting the money. Yeah. Now, coming back to this here, so if we wanted to say the prime numbers, well, x is a prime whole and that's about as far as we can do because we don't have a real systematic way to list the prime numbers or state what they are. Yeah, no, unfortunately. So I don't necessarily like this one, but that's just what we do, especially if we don't have a way to systematically or use anything else than this.
Could you write hashtag for that?
Pound symbol, pound hashtag. Any questions on C? Do we see how this one worked? Well, if we're good with that one there, we're going to go back to the start of this note sheet. And this is the last piece we're going to do. We're actually going to graph inequalities from set builder notation. This will really be the only graphing that we do by hand. And we do this here mainly because it's just on the number line. Circles and shading. Now, if we look at the first one, the first part of this is saying the set of all real numbers x such that we have this inequality here. So when we graph it, we're really just graphing this inequality on the number line. Yeah.
But so like open is like
Not equal to.
okay. So 2 would be not equal to right.
Right, because it's just 2 is less than x.
5 would be
Yes. Since the x is in the middle, we shade in the middle. Because 2 is less than x is less than or equal to 5. Open at 2, close at 5, we shade in the middle. And that's it. Any questions on A? We're ready to move on to B. B, the set of all real numbers x such that x is less than or equal to 0 or x is greater than 4. Possibly. So let's see what we have here. So let's look at the first part, 0. So we would have a circle at 0, yes? Would it be open or close? Close, because it's equal to. So we'll fill it in. Now for this one here, would we shade to the right or to the left? Is x greater than or less than? It's less than, so we want all the values less than it, yes? So it just continues off to negative infinity. And that is right. Questions on this here? We feel good with these two here? We're ready to see how the next one works. Earlier today, that's the second time I've used that one. I think earlier today, like, I don't get it. Like, I think they were joking, so.
let's see.
So how would we do this one here?
So -2.
Yeah, open circle at, and then,
You shade it to the left.
right, we can shade it to the left. Questions on any of this here? Now, some of the ones on the assignment aren't going to have both, because we could just have this here, which just means we only have the one. We can have just one or the other. We don't necessarily have to have an OR statement with both. Went too far. We could have one or the other. Any questions on any of this here? Now, with the OR statements, do make sure to take them one at a time and make sure we shade correctly, because it is possible for them to face where the shading actually goes towards each other, which would end up shading the whole line, or actually end up going in the same direction. I've had that happen on one of the review sheets. They set up and actually both went the same way. Let's look at 4 and 5. Now, 4 and 5 are going to be a little bit closer to how I actually want you to do them on the assignment. I'm not expecting you to make a number line and have it be to scale. Because if we look at number 4, what are our two key numbers that we're going to need for this? -6 and -2, yes? So I have 2 spots. If it was only one of them, we would only need 1. So the one on the left would be what? -2. That's one of the things I do ask when putting this together, is that you do make sure they're in the correct order. Smaller number on the left, bigger number on the right. Negative 6 would be open. And then we would, because x is in the middle, we shade in the middle. Because negative 10, which would be less than 6, because if we said negative 10 is indeed less than or equal to negative 2, but it's not greater than negative 6. Yep. So when it's one statement and x is in the middle, yep, it's just in the middle.
But if it's like the or, then it could go.
It can go opposite directions, it can go the same directions, just do them one at a time. So we have 0 and at 0. So x is less than or equal to 0. So at 0, we would shade to the which way? Left. Because x is what? Less than 0. So all the numbers that are less than 0 are to the left. And the other one, x is greater than 0. All the numbers bigger than 0 are going to be to the right of 10. Questions on this here? Any questions on any of this so far? Are you ready for the next part? That's it. You guys have the rest of the class time to work on the assignment.